No, I did not decorate this room. None of the house, nothing in the house I've decorated. Just hammered it up. That's it.
Hi, and welcome to The Service Layer, a podcast by Logicbomb Media, a development studio here in Atlanta, Georgia that focuses on web and mobile apps, primarily in hospitality. I'm Gary Williams, the co-founder and CEO, and today I'm very excited to introduce our very first podcast. Today we're going to be focused on agents. Let's go. What we're talking about here is an agent that allows you to get some really distinct, detailed information in a complex system. So let's pretend that I am on a retail site and I'm asking, I want to return some shoes. Okay. And the agent says, sure, let me pull up your order. What's the order number? And I say it's 1, 2, 3, 4, 5. And then, cool, found that order. There's 2 items. Which one do I want to return? And I'm like, by the way, can we talk about the variety in this order?
Boots to heels.
So I'm going to say I want to return these boots. And then it says, yes, that's inside your 60-day return window. Maybe this was a EU order and we're on day 40 of 60. And it went ahead and emailed me a prepaid label for the boots to make it that much easier for me to make the return.
Cool.
So that is what we're after. From your guys' experience, how many bots do you think are working to make that happen?
How many bots are working to make this happen?
Yeah, I mean, I would say probably a couple of back and forths. I'd say maybe 3 like agents, right? Initial question, doing some sort of like search through some sort of MCP, delivering that to a bot is what I would think, and then maybe the answer right there. So that would really only be 2.
Yeah, that sounds about right.
Cool. All right. And then let me ask you this, like, how would you define an agent? And just getting prepared for this podcast, like, I gotta be honest, like, I kind of know what an agent is, but I didn't know quite how to define it. Do you guys feel similarly?
Yeah, I mean, to me, an agent is like a chat session, right? So you pull up like a sub agent and it starts a brand new session where there's no history and it's got like a set of instructions. So yeah, that's the way I think of it. Like it's just opening new tabs.
But
Right.
isn't it like also like laser focused on one task or like
But I think that comes with the prompt, John. Like when something like GStack opens up like a review agent, if you can see sometimes in the instructions, it's like you are a really strict code reviewer and you need to check out this, like all these changes that I made, and it sends it over with a fresh, what is it called? With like a fresh context. So there's no, like, it doesn't really know anything other than just what it's been given. And, of course.
I'll tell you, both of you are kind of in the right direction. So let's kind of go through like what an agent is. Right now, like if we were just to hit an LLM and get an answer back, just one question, we're gonna ask it for like a thing, and it's gonna give us an answer out of that LLM. There's no looping. There's no internal reflection. The AI is not alive. It's just forming an answer based on the information you've given it and giving it back to the user. In contrast, the real kind of deciding factor that is an agent is whether or not it is deciding something. It's deciding on its action. So it's deciding to call a tool or self-reflect or hand off to another agent or do something, observe the result of that, and then repeat until it's done.
So, but when I send like a message, right, and it comes back with questions and we're going kind of back and forth, and then it says, all right, cool, I've done this thing. Is that a single agent? And then my next request or message is that spooling up your agent?
That's a great question. And we're going to get there. But for now, let's just focus on what like a single agent is, right? So the single agent, right, is just a thing that is able to decide what to do, right?
Mhm.
And it's able to decide what to do on its own. Okay. Um, what we used to do is what is called decision trees. And so we would go from like step 1 to step 2 to step 3 to step 4. And it was a predefined path that we as programmers kind of built in. The difference is that this is all being decided at runtime. The ChatGPT or the Claude or the whatever is deciding what it wants to do. The model really of from those companies is deciding what to do with the information it's been given, which is pretty important because that means that path can be very dynamic. And then what we really need is to do what we just did is to have many agents that are specialists in one thing or another. Okay. And we can talk about why we want to have specialists, but like these guys have their own little ecosphere and their own little mechanics that we have prompted to let them do what they do. Right. And what we do is we have what's called a controller that basically takes the output from all these guys and kind of helps make sure that it's going to the right place, and in the end delivers the feedback to the user.
Nice.
Okay. We're about to walk into my example, like a full diagram of my example. All right. So when the guest asks the question, can I return these boots? Right. They are hitting basically this front door, this thing called a controller. And that controller manages, is this an appropriate question? Is this something that I even should be answering, right? Like if they're asking how to solve my math homework, like I need to bail, right? Because now the company is spending money answering things that it doesn't want to answer, right? It wants to answer things that have to do with the business. So the controller is, usually putting on the guardrails, right? Or it might be using subagents to do that. And then once it decides where it needs to go, it is deciding where to go next. In programming, this is called a bus, right? A message bus. It is essentially in this model, the bus, right?
Okay.
It is driving the message to the right agent, right? And saying like, hey, I think this is for you, handle it. So your controller is kind of like your starting point. And when working with the client, we would sit down and we would say, what are the questions that we need to answer, right? Like, what do you want this bot to be able to do, right? What do you want this agent to be able to do? And then we're going to build all these agents around it that kind of have those capabilities. Right. So it's going to say, oh, this guest is asking about a return. Let's go ahead and take that to the returns agent. And this agent is determining, it kind of owns the return. It knows all the things that need to happen to determine information about a return, right? So it's going to say, hey, I need an order. Get me an order. And then that controller is going to go back and it's going to go to the order agent and it's going to say, hey, we need the order. And then the order agent is going to say, I don't have an order number. I have to have an order number for that. And then the controller is going to form a sentence based on what it knows we need. It knows that we're at a stopping point, that we can't continue to loop until we have an order number, and we need to ask the guest for some more information. Does that make sense?
Yeah. Super cool.
Cool. So then we ask the guest for the order. That comes back in, and the order is passed along to the order agent. At this point, we need a way for the agent to safely get information from the order DB. Now, this order database could be 30 years old, right? Like this could have been, Neiman Marcus's order database for the last forever, right? And we need a way to get into that. Traditionally, right, we use APIs to get in, but agents work a little bit differently. Agents are using, language, right? An LLM, large language model, to communicate. And so an MCP server kind of gives us the bridge that allows an agent to interface with an API, right? And so this order is asking, this order agent is asking this MCP server, hey, I've got this order number, give me all the information. And then this MCP server is saying, okay, I know I need to hit this API endpoint to get that information from the order database, right? And we've done this several times, and we do this internally all the time. Okay, so that's handed back to the order agent. And then the order agent also knows, like, oh, there's the person ordered 2 items in this order. I don't know which one. They haven't determined, or they haven't dictated which item that they wanted to return. So it knows, like, hey, I need to make a choice off of this. Okay. So again, we pass it back to the controller, and the controller passes it back to the guest. They choose the boots. And so now we've got kind of everything we need to know to decide whether or not this return is valid, right? So we've got the item, we've got the order number, and we've got the policy from the policy agent who's going to determine whether or not that order is applicable, right? Whether it can go back. And so it could go, it could just know all the information. We could have that information in a policies DB so that it's actually updating, like, the website and the mobile app and all this other stuff. You can get as complicated as you want, but somehow this policy agent understands, either hard-coded or through some sort of dynamic store, what the policy is for returning that item. And it's going to make that decision. Okay. So that, like, this right here is really kind of the end of that flow. It's going to say, yep, you're within the 40 days or the 60-day window, and you can return that. Does all that seem to land for you guys?
Yeah, that makes sense.
Cool.
Yeah.
So one of the things that we do over the last 6 months or 8 months or so that has really improved our flow is to have a review agent. That review agent's only job is to look at the original question, look at the final output, and decide, does this kind of answer this person's question?
Okay. Does it do that after the conversation's over?
It can, no. It's going to do that. It could do that at any one of these steps, right? It could do this anytime the controller goes back to the user and just be like, yo, does this make sense? Right? And so it's just kind of a bit of a sanity check. Kind of just using language to be like, does this answer match this question? That's it. Like, that's all they're really doing. Right. And again, this node here can get really complicated. You could have these review agents across each of these nodes. So order agent could have its own review agent, return agent could have its own review agent, policy agent could have its own review agent. Like, you could get pretty nuts with it. It really just comes down to how complex the system is. Right. So review agent's a good place to make sure that tonality is also good, to do like one final check before it hands it back to the controller and hands it off to the guest.
Does it review every message, like, just before responding?
Again, that's up to you. If you tell the controller as part of its prompt instructions to use the review agent every single time, it can.
Got it.
Right.
Okay.
But let's, I think this is a good time to talk about the downsides of this complexity, right? We're talking about, maybe let's just say a medium complex problem here. What would you guys guess are some of the downsides to, like, this setup?
Oh, I mean, speed is the immediate thought, is like, are we waiting for each one of these to respond? Like, I know it takes, I don't know, 5 seconds to get a response usually, even on a simple question.
Yeah. Speed and cost, right, are the big things that you're like, while you're not being speedy, you're spending dollars. Right. Like, that wait time is costing money. And, a good IT friend of mine recently kind of pointed out that, like, throwing a big monolithic model at these systems as a solution, like, that is definitely a mistake. It's going to slow you down, right? They run slower and they're more expensive.
What, define monolithic model? What do you mean? Like a old legacy massive database, or
Yeah. So like think about it like where if like the controller, like when people were first starting, this is what they would do. They would be like, guest would ask a question, and then one like quote unquote agent wouldn't have any kind of looping. It would just answer. And to answer harder questions, they would just be like, well, throw the expensive model at it, right? The
Right.
slow one, right? And maybe that'll solve our problem. That's not the answer. The answer is distilling down individual skills to small models that are zippy and quick and have smaller context windows, but that doesn't matter because you're doing very specific things with them.
Yeah.
Right. And the cost is not linear. The cost is exponential. So what you're going to pay for Haiku is way cheaper than the difference between Sonnet and Opus, for instance, talking about Claude models, right?
Right.
So the smallest model is much cheaper than the middle model is compared to the most expensive model. So
Right.
you just spread that bad boy out so it speeds up as quick as you possibly can. And in the end, it's actually much cheaper, right? And much faster. Does that make sense?
My brain is going to testing, like, how do you know that the cheaper model is going to be able to handle, I don't know, certain queries? Like, yeah, how do you test all that?
Yeah, I mean, you are going to, as you develop these agents, you're going to develop specific tests, right? Golden rules that you're going to run against them to ensure that the prompt you're giving it is able to answer those questions. If you're, and this is just what my anecdotal experience is if your agent is getting so complex, and I'm just going to say fat, right? Like so heavy with prompt information that you're trying to answer, like you're basically trying to like shim in all these answers, it's probably a good sign that you need to split it into multiple agents. Right? So let's give like a resort example. At a resort, you've got a casino and you've got a water park and you've got, swim with the fish and like you've got all these various different services. If you think about them and you personify these agents, if you went to that resort, you're not going to speak to one person that knows everything about all those different departments.
Right.
If you really kind of pretend that they're people, it makes it kind of easier to have a mental model around like what they need to do.
It's so funny how human this thing is, right? Like if you picture that controller being like a front desk or like a call center, right? And the call center doesn't know, like that agent who answers the phone doesn't know that much, and they have to reach out to all these different people. Like that makes that interaction really slow, just like we've got here, right? Or like if it was really complex. But if that, like, if the more that controller can know, the faster it might be. But like maybe like, that person is just like inundated with so much information that they can't answer accurately all the time, or they get confused because of the 7 different policies that they've had in the past for like returning. Like it's just interesting how you can personify it all.
Yeah, that's exactly right. I mean, that is exactly right. I mean, it really comes down to taste, right? You're going to have an engineering opinion, right? Talking to our customers about what the right thing to do is. If it's simple enough, maybe this is good enough. You just have it invert on itself and kind of loop on itself until it feels like it's got a solid answer that is qualified, right? And sends it back to the agent. But, a lot of our customers don't have a simple, what is your address? What is your phone number? That sort of thing. A lot of times it's complicated, so cool. Less steps are better, but only to a point, right? At least you start to simplify and it starts to get muddy the minute you start to expand that capability. So again, it's just about communication with the client and kind of figuring out what it is that they want to pull up.
Good. Are we going to get to see some source, or
I don't have any source in this one. I didn't want to make this for programmers. I was trying to make this for people trying to understand general concepts.
Yeah, no, top level. Yeah, maybe we can
Yep.
dive in on another episode on like what
I think this
setup
is
looks
great.
like.
Like I feel like this speaks to, maybe some developers as well a little bit, that are maybe getting into designing, this.
Yeah, I mean, it clears up some stuff for me that I've been curious about. So yeah, it's good.
All right, so we're going to talk a little bit about keeping the agent on task. So you really want to narrow down the job description. You want to, you don't have control over what the user asks, but you do have control over what's in your .md file that kind of defines, quote unquote, the personality or the, what the agent's job is supposed to do. So you really want to make sure that have as few reasons to exist as possible, and you're going to get the quickest output. Right. So, the return agent might be doing many things, but its job is basically to determine whether or not a return can happen or not. That is its job. Right. So it might be like, hey, I don't have what I need. Hey, I don't have what I need. Hey, I don't have what I need. Okay, I got what I need. Yes, you can return it. You're trying to make it so that it's got one job, and its one job is determining a return. The order agent.
You take that too far, right? If you take that super far, you're going to be going from agent to agent to agent, and like a complex situation, and it could take forever.
Absolutely. Absolutely. Let's say that we could, if there was a system where you needed many pieces of information from different parts of the system or from the client, the user, right? Those agents could actually be spooled up in parallel by the controller. And all of those guys could be going out, figuring out, do I have what I need, before you go back to the user and say, hey, I actually need these 3 pieces of information. And you don't have to ask those sequentially. You can ask those in parallel. You can say, give me the order number. Tell me what the item is. Like you could kind of ask for multiple things at once. And we see this, right? Like we see this in top tier systems like Claude Design, and, OpenAI's got a few things where it'll come back and it'll ask you 3 questions with 3 different options under each of those questions. And so you're like, this one, this one, this one, right? And then it goes back and it does a bunch of different work. So again, like in this very simple example that I just gave of like a hub and spoke, yes, it's probably not the most efficient, but I think it's very easy to kind of visualize what's going on. It's your job to kind of speed test and kind of try different things based on what the use case is and really what the system architecture looks like.
Yeah. At the end of the day, it's all about like that output. Like, how does that experience feel?
That's exactly right. How does it feel? One thing that we have run into in the past is MCP servers trying to giving an agent a single MCP server to go to has, for me, worked a lot better than having an agent be able to reach out to 5 MCP servers and decide what the tool is. It's almost better to kind of decide that at the controller level and then just be like, okay, Mr. Order Agent, like go get what you need to go get. The latency of going to get that and compiling that response is way bigger than the splitting it up into multiple agents and the latency that you get with that. So it's a much clearer path. And if the controller is just kind of deciding what we're going to need, it kind of gives you a single source. Also, as things change and as new problems arise, you've got this one central place. That's why when I talked about changing the tonality of the response, like how do we want this bot to sound, the review agent is a great place to do that. You can basically have an agent that sets the tonality of the response so that if that changes, if you want it to sound like a pirate for Halloween, you can do that, right? You don't have to go change a million bots. You just change that one.
So let's say that that return policy bot or that return policy agent, if it's got that knowledge of the actual current return policy, it's going to be a lot faster than the order one who's got to go look up things, right? Hit the API, wait for a response. Even if your API is like lightning fast.
Yes, and it's not really about the API speed. That's not your bottleneck either. It's the interpretation of the data that comes back from that API. It's the agent turning that JSON response that comes back or whatever the format is, right? It's interpreting it and converting it to a single sentence or an answer or a determination, right? Like that is complicated. Like to decide whether or not and the policy agent's a good example because it is getting back the policy and then it's saying, yes, sir, like that works, like you can return it. And so unless the API is doing that lift, right, the policy agent has to do that lift. It has to do the interpretation part, and that takes a second, right? Again, if you're running on Haiku, it's quick. If you're running it on Opus, it's going to take 30 seconds.
Gotcha. Okay.
You get what I'm saying? So if you do it on Haiku, it's cheap as can be, and it's quick, right? And again, these are just Claude models, but
Can each one of those agents, and I know in like practical like coding realm you can, but in our setups, are each one of those agents like, do they all have their own different models, or can they all have their own models depending on their skill?
100%. And we actually did this for a client as well. There was a portion of their flow that was very complicated. And so only when you got into that need, if you will, right? Because on that particular example, it actually was for a resort, and the user could be asking about any number of things, but this one particular part just needed it needed a bigger context window, right? And we're talking about controllers within controllers within controllers, right? Like we're literally talking about 3 controllers deep. But every controller on the top level was light, and then when you got down into that and you were like, okay, we really do need the muscle, that's when you executed that muscle, right?
Okay.
You didn't do it at the top, you did it at the bottom. Does that make sense?
I think so. I mean, the controllers and controllers lost me a little bit, but
well, like a controller might be handing it off to, let's just go back to our example. Like our initial controller hands it off to the order agent. Let's just say that agent had a very complex set of tasks beneath it. It actually might be controlling a bunch of sub agents below it.
okay.
Right. And so, and in a way, it kind of was like it's reaching out to an MCP server. That node could be another agent, right?
Yeah.
Again, like you're like trickling down using this, letting the LLM determine at runtime, and that's the distinction from the decision trees of yore, right? Is that we're not doing it with logic. We're letting the LLM decide, like, how do you trickle down that tree, and then how do you bubble back up to the response?
Okay. That's so.
It really is kind of a fun thing where you can like sit down with some graph paper and like literally mind map out how you think it should be. And kind of use that as your hypothesis, and then, shape it to make it quicker or smarter or, whatever. Because there will be times where you're like, oh, I thought that would work, and it just doesn't. It's just too much information, especially when you've got thousands of pages with information scattered all over Kingdom Come. It's not just a website. It's also notes. It's also a policy DB. It's also this. It's also that. Sometimes you're going to get it wrong, right? And one of the things that we've integrated in, and I think you see this a lot, but not as often as I would think, is giving users the ability to feedback. You can go as crazy as you want with this. You can have an agent that was running behind the scenes that is looking at users every single night, users' feedback, and looking at the conversation history that they had and making changes. You could have a human go in there and review negative conversations.
Well, that's what I was thinking the reviewer was like kind of just sitting there, like that, the boss just standing back there and being like, oh, what are you doing? That's a terrible answer. Or like, and then being able to log that somewhere saying this was a bad interaction. And then, as a developer, you can go in and just like, rerun those and, like optimize the whole flow.
You could ask your guests for reviews, but you could also say, hey, if it gets here and rejects it and it goes back through the loop, because that could happen. It could go through the loop. It could say like, nope, that's not a good answer. Go back to the controller, and the controller could go back to the agent and say like, refine this, or the controller could refine this and try again. Right. And so the guest never sees that crappy response. They just kind of wait a little bit longer. But you could have behind the scenes, this could log this out to that same system that the guest is reviewing to.
Yeah, that'd be dope.
Right. And so now you've kind of got this self-improving system that becomes the Terminator after 5 years of running and take over the world and starts building robots that, we've got to hunt down with John Connor.
Starts hunting us with high heels.
That is great.
So having multiple ways for those review systems to go in. The only thing I would say is make sure you log everything. Having it can get ugly. Like you can give it like, hey, it went through these agent flows and all this kind of stuff. Knowing as much as you possibly can about the system and giving either a human or, an AI agent the ability to kind of interpret and understand where things maybe went wrong is really important.
Awesome.
Nice.
All right. Any other questions before we move on?
Nah, man, that was great.
Call it a day.
Nice. Good stuff. I learned something. Yeah.
Awesome.
Yeah.
All right. Well, I really look forward to doing this some more with you guys for sure.
Awesome.
Thanks everybody for
Your
the
time.
time.
Your time.
Thanks everybody for my time.
Thanks everybody for my time.
You're welcome for my
I
time.
don't know what you're telling them, John. No, yeah. Say that. You should just be like, all right, everybody, you're welcome.
All right, everybody. You're welcome. We'll see you in the next one.